And at this point, we're going to just quickly pull up some basic Civil 3D capabilities and look at the SkySAFE Terrain capabilities. So I wanted to get the prospector open in Civil 3D, as this is the main form that I'll use to interact with Civil 3D surfaces. But we're going to start our assessment here with some SkySAFE Terrain. There's a specific command for it over here, and that is where it's expecting us to import some delimited data. Now in this case, I have a file. It's a smaller portion of the overall tiled terrain that I'm going to use for Civil 3D. So it's been cropped to be a smaller tile. I've also elevated it to be 20 meters higher than the actual terrain. So when we take a look at the elevation reporting, we can get some difference out of the two results. So there's a little bit of a method to the madness there for why I did it. I wouldn't normally change its elevation, but the terrain has a number of points in it. By default, the options here for the vertex count when importing larger tile sets will limit each tile to be up to a certain number of points to define the surface. I know this data set's got a little bit more than 15,000 points, or little less than 15,000, my apologies. And I want it as a single tile instead of two tiles, so I'm going to increase the vertex count. I could also draw contour lines. And what this will do now is, based on reading in the delimited file, take a couple moments. There was actually 10,793 vertices found. It's building up the height and drawing it, so we're getting our contours being drawn. So this would work in AutoCAD or BricsCAD. That is not a vertical product that's intended to do grading and earthworks like Civil 3D is. So we have a mesh-based surface here with contours that makes up my terrain from my input elevation or data. And I have a few obstacles that are within the area here. We can kind of see them highlighted with the grip points. There's obstacle 8, obstacle 7, obstacle 5, and I think obstacle 6 is going to be the other one that's in this quadrant too, or in this tile. So with the SkySAFE Terrain included, we could now evaluate the obstacle intersections. The obstacle evaluation initially was to the ARP. Now that we have a SkySAFE mesh, we can include that. And so I'm going to leave it back as a text-based label rather than the tabulated form, just because we're looking at the few obstacles that are only right there in that area. And if you remember, it gave us a surface height and it gave us a height at ARP. This time now it's going to bring in the SkySAFE terrain elevation and give us some reporting on that height for the height from there to the surface. All right, so last regeneration is happening. Now I can zoom in. So here, rather than the ARP, we have a height above the terrain for that 70.88 meters. So what it's telling me in this point is that my obstacle, it seems, is penetrating, but I might also have a terrain issue, since this delta penetration is about the same thing as well. So we'll report not only the obstacle height in relation to the terrain or the ARP, we'll now be able to take a look at the terrain and what the terrain does with the existing ground or the obstacle surfaces. So let's evaluate the terrain intersection. Here we'll use the SkySAFE mesh, the only one that's in the drawing right now. It's going to go ahead and process the results. And visually, based on the default, it's marking all of the vertices along the mesh that are above the surface height elevation with a red dot. And it is at the same time writing out for me into my directory where my project is open from what's called an OLS height field report. I've run it a couple previous times, hence the increment here. But within this document is a CSV listing of all of the points for the terrain, X, Y, Z, what their height is, and what the height of the surface is, what the delta penetration is, and which surface it's affecting. So only the penetrating points from the terrain are coming out now to let me know what's being a problem. We said the default was red, so that's one way of looking at it. The other would be to go back to the surface settings and to change over from using for terrain intersection a simple red to use a height dependent look. and we get a graduated color-based representation. So the lighter penetration starting to happen around the edges and the heavier penetration in red starting to happen in this area right here. Certainly we could look at that delta range that's back in the spreadsheet to get more specific information on the locations and the elevations.